All right, welcome everyone. So this is our workshop on security engineering in general. Um, so we wanted to give this workshop because we'll show a slide to introduce ourselves at first, but we worked at different companies where we realized security engineering ends up being the same thing over and over again. Like you find yourself like building the same tools, integrating them, coming up with a process. And so there's a lot of room for like automating all of that in a way that can work for like just everyone. Um, so we'll go through introductions because there's only a couple of you. We can also like make it more engaging, and you can like maybe tell us what your level of experience is and what you're trying to get from this. And we're mostly going to focus on static analysis and dynamic analysis. We have a few labs you can go through if you want to practice like how to actually implement or integrate SAS and DAS tools. So first, some introductions.
So I'm Omar. I'm currently a staff security engineer at Betterment, where we do a lot, but it's kind of like 401k type of stuff. That's a product. I lead a team of product security engineers. So that's securing the code, the infrastructure, the process that gets the code out to that infrastructure. Prior to that, I worked at OkCupid and Etsy, and I'm also an advisor at the student-run security research lab at NYU.
And I'm Mark. So we actually work together at Betterment, um, and we work in a lot of the stuff that we see today. But I started out as a penetration tester at NCC Group, and then I had a few jobs. Uh, I One of my last jobs was at Activision, which was we were mostly doing static analysis, um, mostly on Call of Duty, but on some other stuff as well. And now I am director of engineering at Movable Inc., a director of security engineering, and I also taught at Columbia Boot Camp for security. Um, and why we created this workshop is, as I mentioned, like we were just doing these across all of these different companies, and it was kind of like the like regardless of what industry your company is, these principles are still the same. Um, so usually we don't do rounds of introductions, but since the class is small, I was curious, like if you want to talk a little bit about your experience or like how much familiarity you have with those tools. Do you want to start?
Hi everyone, my name is Joshua Mead. I am a security specialist at ReliaQuest in Tampa right now. I am starting out pretty new. I was a IT specialist before then for like a year at a nonprofit, so not a huge amount of experience when it comes to security or engineering. We have done a lot of SIM health and ingestion stuff recently that I've
Nice.
been able to do. So kind of like getting into that. I did a AppSec course recently, so
Mm.
the CI/CD stuff and like Kubernetes Docker, like it's definitely been something that I've been interested in, but never really got a chance to pivot into it. So I'm really excited to see what you guys have to say.
That's very cool.
Yeah,
Nice, nice.
yeah, you'll see. That's actually kind of one of our intended target audiences,
Ideal audience. Yeah,
is like
yeah.
pivoting into security engineering.
Yeah, it's definitely something I've been interested in a while now. So it's cool to finally, have the chance to learn more about it.
Oh yeah, we'd love your feedback at the end, especially. Do you want to go next?
Yeah. My name's Christopher Fox. So I'm a sysadmin. I work for Stitchfix. And so I do some work with the security team. I'm really just trying to break into that more. I'm also kind of stuck
Nice.
in that, like if I went to like a security related role, I'd take a pay cut, may not be fully remote. So I've just kind of been just building my skill set and just interested in more like the defensive or the like just keeping the infrastructure secure side of it. Not so
Awesome.
much
Yeah.
like I understand pen testing and like some light hacking skills, but yeah, I'm really interested in this
Awesome.
Nice.
increasing
Very
my
cool.
skill set.
I am also a fan of remote work.
Yeah, I know it's kind of like I may not be fully remote. Yeah, I potentially take a pay cut, so it's like it's kind of like sitting in my position until
Yeah,
the tech industry heals a little bit.
yeah.
Yeah, I feel like having some of this data and skills under your belt will kind of help you make that decision a bit more confidently.
Yeah, eventually I won't be afraid to. More just like the pay cut will be okay, maybe less severe.
Also, I think you'd have more options to go elsewhere too.
Yeah, definitely.
Cool. Sorry, I don't know if you're participating. Yeah.
Hell yeah.
Didn't mean to put you on the spot.
No, that works. My name is Matthew. I currently work as a SOC analyst for the Center for Internet Security.
Nice.
They're known for their controls, benchmarks, and that sort of stuff. But we work on helping government entities protect their assets. I guess the question is why I take this course yet. So, working as a SOC analyst, I want to get that more architectural perspective. Really, why is my scene popping up with this sort of telemetry, right?
Right.
And you mentioned a little bit about best practices and how to build a good program. I'm interested in that because a lot of these government entities don't have the resources or just capability in general to build up something like that. So I think it'd be very a good skill set to have in general, but I think I can see a lot of use in what you guys are going to teach.
I give some names.
Yep.
Yeah, keep.
Hi, my name is.
Oh, nice. Nice.
Nice.
Nice.
Nice.
I always say that security needs more data engineers. I think it's a very important pivot. Like we definitely need people who are good in data engineering. So that's also yeah.
Right, yeah, my name is Amir, and I'm application security engineering. So
Oh, nice.
focus primarily on things like SaaS, DAST, and
Okay, perfect.
like securing the CI/CD pipelines and all that stuff. And work at a company. It's like a real estate SaaS platform. So lots of engineers, but few amount of security engineers. So we need to scale. And I'm interested to see like the different patterns that are implemented, and
Yeah.
what are the preferred patterns, like you mentioned, like how do you scale DAST or SaaS and all those tools. So be interested to see.
Okay, well, I'm just curious, what SaaS tool have you been using the most?
GitHub Advanced Security. So
Okay, yeah, CodeQL, yeah.
So you got money. That's
Cool.
why.
Yeah. It's expensive, yeah.
Oil.
Okay, cool,
Nice.
nice, awesome, yeah. I know you just joined late. We're just going around seeing like the context of like what's everyone's level of experience with like static analysis, dynamic analysis, or like what your experiences in general. It, it doesn't matter. Static analysis or dynamic analysis is like the things we're going to cover today.
But also like
But
why you're
just like
here, your interests, that kind of thing.
yeah.
Nathan, True Anomaly, we're like a space company that does like tactical maneuvers in space.
Oh, nice.
So we have like space assets, like vehicles that we talk to in space. My job is to make sure that the communication from the ground to the vehicles and vehicles back to the ground is secure.
Nice.
Specifically the communication. Awesome. That's super cool. Oh, super cool.
Ground software. So yeah, we run like SaaS tools. We don't run DAS. We just run SaaS.
Awesome. How big is your team? How big is the team?
It's the startups. Like 4, 5.
Oh, okay.
Nice.
But that's very cool. Yeah.
I'm glad first that's the bar high.
Yeah.
Cool.
And in the back. Ooh. What do you teach? Ooh. Very cool. Very cool. Okay, awesome. That's awesome. Okay, cool. So since this is a small class, feel free to just interrupt us at any time, or even if you have like any anecdotes to share. If you're like, oh, this is how we do it with CodeQL, like if you'll feel you can share whatever you want.
Don't get offended when like, promised landed, which was I thought that I go to there, so
No worries at all. You don't owe us. You can leave anytime you want.
Yeah.
So
That is a cool talk for what it's worth. So.
we would have gone there if we.
Yeah.
Totally.
It's also the end of the day, so you got places to be.
So we're first gonna introduce like what is continuous security. You wanna start with that?
Sure, yeah. So kind of laying the foundations of what we'll be talking about. So continuous security, a lot of different ways of calling it. You might have heard of it referred to as shifting left. It's kind of like the buzzword approach, but the general idea is that you've got the software development lifecycle. So you kind of start with the constraints of the project. You turn those constraints into design document and architecture document. You start writing code, and then you eventually deploy it. You deploy it, then you start maintaining it. And so the thing that the industry has learned the hard way over the last 20, 30 years is that security issues are a lot more expensive to fix the longer you wait. So if your code is already out there in production and you find that there's a security issue, that's going to be a lot more expensive because you need to fix it, but also you need to make sure that you haven't already been hacked. You need to make sure that the fix that you roll out is compatible with stuff that's already out there. So it's kind of a really expensive battle, both in terms of effort, time, money, all those things. So our goal of this talk will be to, or this workshop rather, will be to do as much of the security detection early on in the pipeline when it's easier to fix and find these vulnerabilities. And simply the continuous part just refers to automating. A lot of this looking for bugs, like AppSec, reviewing architecture documents. You can do that right now by hand, but our goal is to automate as much of that as possible so that we can do a lot more than just that. So our goal for this workshop is to get you familiar with the concepts more so than the tools. Of course, we have preferences for tools, and we're going to make that known. We're going to make that clear here. But we're not going to be teaching you these tools. We're not going to sit you down and say, hey, look at the manual. These are these flags that you need to know. We're instead going to say, here's the questions that we ask when deploying the software. Here's the constraints that you will run into deploying the software. And this is going to be true for any of the software that you work with, whether or not it is the one that we chose. And so our goal for you to be able to say, okay, we might not use SendGrip, but we're going to use GitHub Advanced Security. We might use any number of other tools, but the fundamentals will be the same. And that's what we want you to take away. And so that's where the DIY part comes in, the do it yourself. So you might be part of a small company that's got 5 people. You might be part of a large organization, the first security hire, whatever. But the DIY comes in with you being the one making the decision. You choose a software and make the decision that makes sense. Who is this workshop for? So it sounds like we've got basically a wide variety of people here and a really good distribution of the intended audience. So AppSec people looking to broaden their impact. So like if you're already looking for bugs, if you're already capable of finding bugs, this talk's for you. If you're a security consultant, you're looking to go in-house. We've seen that a lot where someone's job is to find bugs 40 hours a week, but when you go in-house, that might no longer be the case. Software engineers looking to bring security into their practice, so doing a lot more than just writing code or looking for bugs in your own code. Technical people looking to pivot into security engineering. You're already working on a computer 40 hours a week. How do you kind of pivot into InfoSec? That's a question that Mark and I get asked all the time. I look at all this complicated tools for a living, but how can I bridge that gap? And then also the last thing you want is being the first security hire is a tricky position to be in. You might be not super experienced in InfoSec, but still find yourself in this kind of position. And so you're tasked with establishing the baseline security program for your organization. We're hoping that this talk will set you up for success, regardless of which one of these you are. And like Mark said, feel free to interrupt at any time. We've got a very small crew here, so you got questions, anecdotes, corrections, even like literally just shout them out. Yeah. So these are the concepts that we'll be covering. Each of these concepts can be their own talk. They can take months or years of work, so don't feel like you need to pick up on everything right now. We'll be going pretty quickly, to be honest, but the goal is for you to get started and kind of fill in the gaps at your own pace later. Hopefully you kind of get an understanding of what the gaps are after this workshop. Cool. So this will be hands-on, or hands-on as much as you want it to be. So if anyone wants to actually get started, we set up a GitHub organization. We can add you if you want to start forking things. If not, you don't need to. We're going to be reading stuff, not quite line by line, but chunk by chunk, and hopefully give you the concepts even if you're not actively participating. No pressure.
Yeah, so mostly we're going to be setting up GitHub Actions for automating SAST scans and things like that. So if you want to clone them and use them in your own repos, let us know what your GitHub usernames are, and we can add you to the org where our stuff is. So we'll give you a few minutes in case you want to do that. You can just give me your GitHub username and I can add you, and then over there you'll find the we can point to the
repo that we'll be
the
working
repos,
with.
yeah.
Yeah.
That works.
But am I saying it a lot?
Yeah. Okay.
I love that. Yeah.
Okay, I think I found it.
Thank you. With the green and white.
Okay. I need to.
Yeah.
Tester,
That's just me.
3 Z's, and then 22.
Okay. Tester 3Zs. Okay.
What's up?
Okay, I'm trying now.
They're just a little blurry. Unless I'm the only one who's seeing it. That's a little better.
Oh, I can see what you mean, kind of like the angle.
Bottom, like third.
Okay, yeah, I think I found you.
Just a little out of focus. A little next to the
Thank you.
They can make the top out. That's my
Yeah. I'm trying to memorize it. Okay. Oops. Okay, I think I found you. Okay, you should be getting an invite. I forgot the invite. Does it send it by email?
I think it's by email actually, so just double check that.
The email that's associated with the GitHub.
You can go to your org in the profile and you click accept.
Oh, it shows it up there? Okay.
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 That's good to know for later.
But adding it, can you send an email too if that works?
Okay.
Okay, nice.
Yeah, this is a slide that we were going to leave it at so that people could come in and.
Yeah. So in this GitHub org, the org is called SecEng Sandbox. We have a few repos. We'll explain what they are, but there's also we're also going to be using Docker. So just to make things simpler, you can run some of the tools, but also when a sample app we made through Docker. And so if you don't have Docker installed, their docs just give you an easy way to install it. And then you can verify it's installed through like Docker pull hello world.
Yeah, basically, if these Docker commands work, you should be set.
But Docker is like less important than GitHub, I guess.
Yeah.
Because you can still do like most of the things without it. So if anyone else wants to be invited to the GitHub org, let us know your username. And then the second step is optionally install Docker if you don't have it. And then one of the repos in the org is going to be called Jester Social. So you can fork that. You can click on it, create your own fork, and then you can clone it locally if you want. If you need any help with any of those steps, let us know. We'll give you like a few minutes to the. Oh, this is all. What is this? This is awesome. This is so
What is this
cool.
device?
It's hard to describe because it can do a lot of things, but it's basically a Steam Deck with a keyboard.
Sick.
Wow. You built it?
No,
Oh.
no, actually. I wish I could.
Okay, I found you.
Who manufactures it?
There's this Hong Kong-based organization called GPD. Always
Nice.
safe to clear everything from the thing before you actually use it, of course. But yeah.
Oh, what's your you want to show me the oh, nice handle.
Really cool.
Mm-hmm. Found it.
Yeah, also, even though we'll be dealing with GitHub, don't feel like you need a developer environment ready. We're not going to be like, writing algorithms.
That's why we use Docker, because you can just pull whatever we need in one container. Did anyone run into any issues just getting into the org?
Everyone got Docker set up? Yeah, that's perfect.
That's fine, yeah.
Also, you don't even need to do it. So
Kind of want to. Just this late in the day, I won't be able to like pay attention.
yeah.
Yeah, totally, that's fine. And so Jester Social is a sample web app that we built, and the idea is like when you're working as a security engineer, you're always working to secure a product. And so we built one that just like is self-contained into a Docker container. And so we're going to be pretending that we work at a company where this is what we need to secure. And so this is, we're going to try to run static analysis on code that's being added to that repo. It is also, we'll see later for that, just to make things easier, we also hosted it on jester.social, the domain. So if you want to, you can actually use it. It's like a fake social media app.
But it works.
Clown-based fake social media app. So you
Not
can,
unlike
yeah.
Twitter.
True. Okay. So we can start moving on.
Cool. So let's just jump right into it. So static application security testing we'll be referring to as SaaS. It's quite a mouthful. So in short, static application security testing is automating the code review process. So when you're an AppSec engineer and you're looking at code, you're often asking questions like, is this function being used correctly? What's the impact of it being used incorrectly? Do I control the input that this function receives? So you'll find yourself asking a lot of these questions. And the thing about these questions is that sometimes they can actually be relatively simple to ask and simple enough so that automated software can actually ask and answer these questions for you. So not only can they do this stuff faster, but they can do this a lot more efficiently. In the time that it takes you to find where this function is being called, SaaS will have already found it and tracked down all the inputs that it takes. So here's an example piece of code from Python Django API with a simple vulnerability in it. Does anyone want to take a guess where the vulnerability is?
Since it's on the screen, second bullet point. Oh, where it is.
Yeah.
The sixth line.
Yeah. Exactly. So there's a old school SQL injection vulnerability. So basically, you've got your SQL query right here, and then this is user input. So you're putting user input in a SQL query, and now what happens is if I control item ID, which I do because this is a public website, I can put in my own stuff that will end up in this SQL query, and I can say instead of select item where the ID is this, I can say select item where ID is this, and also delete everything. So this kind of like this conversation that we just had is something that it turns out computers can do. I asked the audience, where is the vulnerability? And I had to kind of explain it. That can be something that a piece of software can handle for us. And in fact, we're going to do that. So SemGrep, has anyone heard of this piece of software? Cool. So SemGrep is kind of the household name in open source application security. The entire premise is that it can do a lot of pattern matching. So kind of the quick identification of SQL injection that some of you did maybe even without recognizing that you did it. This is the kind of thing that it turns out it's pretty easy to represent as a pattern. And so SemGrep is actually really good at doing that at scale. So we looked at one file, and the conversation we had was like, I don't know, 5 minutes. SemGrep can do that in a couple seconds for literally tens of thousands of files. And so if we run SemGrep against the file from the previous slide, we can see it actually does exactly that. It identified the line number, set possible format SQL query, and even gave a suggestion. And the thing that I like about SemGrep is that they've got real solid documentation. So it even included a link to this website that if you go to, it'll tell you, this looks like a SQL injection. Here's how you can confirm, and here's what you should be doing instead. So the thing that I like about SemGrep is that, obviously I'm reading this out loud to you and taking some time doing that as a security engineer. But the thing is, you all could have done this on your computers right now. Any one of your coworkers could have done this without needing any of your assistance. So how is automating SAST useful? It's kind of obvious. It saves you a lot of time. So one thing is the SQL injection that I showed you is pretty trivial. It's easy to find by hand, but kind of difficult to do at scale. If you have software doing that for you, what ends up happening is that you can do this for, like I mentioned, tens of thousands of files, and you can rest easy knowing that no one is going to introduce a vulnerability like the one we just saw. With that time that you save, you can work on more complicated issues. It also increases the impact that you can have as a security practitioner. So I mentioned earlier, one of the ideal types of people in the audience is someone who works as, for example, someone in AppSec, but wants to multiply their impact. Someone who has a consulting background and wants to go in-house. This is one of the ways that you can do that. By having SAST handle this for you, you no longer have to worry about finding each and every little SQL injection. You can know that the software is going to do that for you. And most importantly, you're no longer the blocker for establishing a baseline of security. A lot of people, especially in older, more heavily regulated industries like finance, a lot of people will say working with security is a pain in the ass because they have to review everything and they're kind of sticklers about every little thing. Having a piece of software like this do that for you means that they can remove you from the process in a way that's safer. And also, you would probably hate it too if you needed to review every single piece of code that goes to production. So, like any piece of software, SAST has its limitations. We can't just install it and say, yep, I did my job. I will collect a paycheck and head home. So one very critical piece of information is SAST tools do not have context. So they can look at the code and they can understand that there's a vulnerability, or it looks like a vulnerability. It looks like there might be a vulnerability, but it cannot decipher your intentions. So if, for example, you're working on a piece of code related to login and you're accepting a password, you might encrypt that password and use a wrong encryption algorithm. What SAST might say is actually, you should be using this encryption algorithm instead. But the fatal flaw here is that you shouldn't be doing encryption at all. You should be using hashing for your passwords. And the thing is, SAST cannot tell that you made this mistake. And it it simply cannot understand your true intentions behind writing this code. So basically, SAS can tell the difference between these two things, but it can't tell you that you should have been doing some other third thing instead. So I think this is the key point to take here, is that SAS tools are meant to augment your capabilities. It's not meant to replace them. So, an organization cannot say, or should not say, that we don't need to hire security experts. We've got SAST. That doesn't really make sense. So another limitation is that SAST tools are false positive prone. So like humans, they rely on pattern matching. And pattern matching means that you're going to see things that aren't there, or see things that, or not see things entirely. And so SaaS tools are notorious for identifying a ton of vulnerabilities, and it being the case that none of them are real vulnerabilities. So typically in the real world, you'd be tuning your SaaS tool. So that might mean configuring the rules to be less sensitive, know when something is high severity versus low severity, or even just delete rules altogether. You being the employee at your company, you know what works best. And so, if you keep getting false positives about SQL injection, but your application doesn't even talk to a database, you can just turn those off. So deploying static analysis tools. So for larger organizations, like I mentioned, you can't just install it and walk away. At a smaller organization, you might be able to do that because the false positives are a little bit less tedious to deal with. And so this is true for all security tools, not just static analysis tools. You need to set them up in a way that your coworkers can engage with these tools, so that you're not wasting your own time. What Mark and I have seen at other companies, is that we'll join a company and we'll see that people at the company hate this one security tool. It's always slowing them down. And honestly, I've considered to be a bit of a red flag when employees at a company know security tools by name. It's like, why do you know this tool? Oh, because it keeps slowing down my builds, because it keeps giving me annoying pop-ups. I think that's kind of a red flag when people know tools by name. But yeah, so generally maintenance is something that you want to get really good at, and it's a critical step that people forget about all the time. So this is kind of the general workflow that we've seen work really well when deploying SaaS tools. So first, obviously, you want to run this tool on your own code. You never want to deploy something that you haven't run yourself. I think it's poor practice to do that. I've seen people do it before, and it bites them in the butt every single time. I would not recommend it. And then you want to create documentation on interacting with the tool. So you want to figure out the best way for your coworkers to self-remediate as much as possible. Like with code reviews, you don't want to be the one slowing people down. So if someone can read a piece of documentation and unblock themselves without having to talk to you, even better. And then deploy the SaaS tool in a report-only mode. So the general idea is that you can deploy a tool like SemGrep so that it can find issues without blocking. Because what happens is, no matter what, when you deploy a new tool, you're going to have false positives, or you're going to have real issues. But you don't want to deploy a tool and kind of block people accidentally, unintentionally. We've seen it happen before, where someone will deploy a tool and, over the weekend, or when you're not around, there'll be like an incident that someone needs to deploy code right away, and it's your tool that's blocking them. And this is the next part, is a tuning stage that I mentioned. You want to remove false positive prone rules. You want to delete some rules altogether. You know your organization best. And so this is going to be work that you do that's informed mostly by the first step. You got firsthand experience, and so this is what you know what to do. And once you've got your SaaS tool, whether it's SemGrep or otherwise, in a stable spot, what you can do is actually start blocking. So in the third step, if there were a SQL injection discovered, you would still let them push it, because you're still in a discovery phase. But at this point, you've made enough observations that you can say, okay, at this point, anything that our tool discovers is likely a true positive. And so these are the 3 steps of the 5 that we're going to be covering in this workshop. So let's get started by running SemGrep on our code. If you install Docker, this is going to come in handy. If not, that's totally fine. This is the command that you can run at your own pace. You don't have to do it right now. We'll be distributing these slides, and so you can kind of, when you're not surrounded by other people, when you're at a desk at home or whatever, you can do it. So this link just turns this into a copy pastable thing. You don't have to actually type it up by hand. There's also like the word SemGrep like 3 times back to back, which people struggle to type correctly. So don't worry about it. So when you run SemGrep on the code that we created, you get a bunch of vulnerabilities. We see a bunch of these guys, a small handful of findings. It's a little tedious to actually comb through these and figure out, this is a vulnerability, that's not a vulnerability. In this case, the sample app has maybe 6 or 7 of them, so it's not so bad. In an enterprise setting, if you ran this on, for example, your employer's flagship application, you might find yourself with hundreds of vulnerabilities. So that's going to be a thing that you really need to keep in context. So the reason why I bring up the enterprise setting is that you will actually need to go through those findings, you being the person introducing the tool. You should not expect other people to go through these findings for you because you are the subject matter expert. You can definitely and you should lean on the people who wrote the code to help you discern whether or not there are vulnerabilities. But the reason why I say that is because this is going to be a crucial step where you might find that you've had a vulnerability in your main application for a long time. This could be months, years. And if you're looking at it for the first time, this might be the first time anyone sees it. So for example, if you find a SQL injection in your application, you will probably want to pause this project and start an incident. The concern is that with a live SQL injection vulnerability, someone could have exploited your company, your employer's website application all this time. Your database might already be on sale. These are things that you need to be worrying about right now. SAST can wait. So just kind of keep that in mind. So in this first exercise, we ran SemGrep by hand on this code base. But the problem is we can't keep doing that. We're not going to say every time you want to run, every time you want to introduce a change to the application, come to me and I'll run SemGrep on it for you. That's not scalable. That's a waste of your time. That's a waste of their time. So what we're going to do is use GitHub Actions to automate this for us. Is anyone here familiar with GitHub Actions? Okay. So GitHub Actions is GitHub's product for automation. It's typically used for deploying software. So for example, if you push a new version of your software to GitHub, what you can have GitHub Actions do is deploy that for you. So in a very old school way, if you push a new change, you might be the one to push that to your web server by hand. GitHub Actions can do some of that for you. So what we'll be doing is when someone opens a pull request to this application, we will ideally catch it before they can merge it. So we're going to do this in 2 parts. We're going to do this firstly from the perspective of a security engineer where we're setting up these integrations. And then we'll do a second part where we're the developer introducing the vulnerability. So this is the step that we were talking about earlier. We're going to fork gesture social and then introduce it. Since we've got a pretty small crew, I can actually just do this myself and hope it works. So this is the main application that we'll be working with. And what I'll do is I will fork this. Oops. Interesting.
Because you already have it forked there, maybe.
Yeah, I think that's why.
Just go to the fork directly.
Yeah. So this is my fork of the application. And then what I will do is oops. Cool. So I forked it. I'm on a clean slate. So what I'm going to do is set up the GitHub actions. So all the files that we'll be working with are going to be distributed via links. So if you work on your own time, you can literally just click these links, copy and paste as needed. Like we mentioned earlier, our goal is for this to be more conceptual than hands-on, line by line, manual pages kind of thing. So copying and pasting is kind of like our goal for you to be able to do. So what I'm going to do is, let's see, it says,
Question for you.
yes, what's up?
In your experience, are the community rules good enough, or do you, in your organization, do you use the pro rules, or do you just like write your own rules? Like, what do you do?
Yeah, that's a great question. So in my case, my employer, we write mostly Ruby. And so we found that the community rules are actually pretty good. That's been really good for us. Um, so we use the community rules for that. And then we write our own rules specific to our organization. So we've got internal libraries, internal frameworks that we write rules around. I think Mark has a little bit different experience given that he's worked on different types of code bases.
Yeah, I'll talk about it when we're wrapping up the SaaS section because it's a really good question and I already had like some content on that. But essentially, what he says like it depends on the language. It's very language dependent, the quality of the rules. So
Cool. So what I'm doing right now is just installing the GitHub action. And then I will commit the changes, commit directly to main. And so now we've set up a GitHub action. So actually, that's not particularly legible, is it?
but first, just go back up a bit. Yeah, just at the top, zoom into the just the path. I just want to show the GitHub actions. The way they work is they're basically you're telling GitHub to run infrastructure on your behalf or that you can use to automate running scripts or whatever you want. And so you're not hosting the infrastructure. GitHub is doing it for you. And the way they work is you have to create a folder. It's a hidden folder called .github. The dot is crucial, and then slash workflows, and then slash anything .yaml. And YAML, if you're not familiar, it's one of the most atrocious languages. It's horrible because the spaces, the number of spaces, the indentation levels matter. So yeah, just be mindful. Like sometimes they'll run into error, and just because the indentation is at the wrong number of spaces.
Yeah. So that's actually a very important piece of detail is that GitHub is going to run this infrastructure for you. So the reason why that we want you all to fork this to your own GitHub is that uh, every user gets a free amount of credits with GitHub rather. And so by forking it, you get to use, I don't think they expose it to you, like they don't tell you how many credits you have, but you can run quite a bit there. So to kind of run us through this file, what we're doing is we're setting up a GitHub action called sendgrep scan on pull requests, and also whenever someone merges a pull request. And so what we're doing is when someone pushes a new version of the code, we're downloading a copy of that code. So the infrastructure that they set up will download a copy of our code. We're going to use SemGrep to scan that code and send it to a file called SemGrep output. And then we're going to send that file to GitHub. So what this means is that it will find vulnerabilities in your code that you've just updated, extract all the vulnerabilities that it can find, and then send it to GitHub for your own analysis. And then this is how we do that. So we'll see what that looks like right now. So firstly, what we did is we set the GitHub action. Now what we're going to do is testing. So we're going to take this from the developer perspective now. So I'm going to actually update the code. So this is the updated code that we'll patch it with. And you will see one crucial detail show up. So I'm going to open a pull request. So a pull request is typically how the developer proposes changes to a repository. In larger organizations, pull requests are mandatory and will be the blocker for new code being merged. Engineering organizations use this as an opportunity to do code reviews. So not necessarily from a security perspective, but from just a code quality perspective. And so we're going to pretend to be a software engineer at Jester Social by opening this pull request. So I'm going to create a pull request, update Jest's controller to be faster.
And just for context, Omar usually works from the command line. He's only doing this to illustrate how to do it without the command line, but
So I'm going to create a pull request, and then we'll see this is much faster. So this is a code change that I'm introducing, but what you might notice is that this optimization, in quotes, the quotes are very important, introduces a vulnerability. So the thing is, bless you, my goal is not for you to understand the vulnerability specifically. To be honest, the vulnerability itself does not matter. We're not going to be exploiting it. We're not going to be understanding the concepts behind the vulnerability itself. But the more important part is we're going to be catching this automatically. So let's see what our GitHub actions did. So this is a GitHub action that we created. And then this is where SemGrep ran. I'm going to had 13 findings. So that's a lot of vulnerabilities, and let's see if we can find what they are. It's a little suspicious because, I made just one change. Okay, so it caught our SQL injection, and it was nice enough to comment on the line specifically where the SQL injection is. So this is a really valuable part that, none of us have to know what SQL injections are. What we've done is we've identified it on behalf of the developer. So ideally, the developer will know what it is. If they don't, there is some documentation that SemGrep will take them to that says what they can do. Alternatively, consider using ORM, which will protect your queries. If they're working in Ruby on Rails, which we are, they'll know what that means. Yes.
That didn't show up when you were first in files change, but it just took a moment, and then you went back and it was there, right?
Yes. So that's actually a great observation. So the infrastructure that GitHub is running for you, it's ephemeral. So it takes some time to come up and then come back down. And so SemGrep itself is actually really fast, but there's going to be some bottlenecks in the infrastructure itself. So if you don't see anything when you're working on it yourself, also, like, if you have this page open and you don't see anything, it's not going to appear. You'll need to refresh the page for it to show up. I sometimes forget that myself. So now if you scroll down, you'll actually see vulnerabilities in files that I didn't even touch. It says right here, files changed 1, but it's like, okay, prod compose has a vulnerability, config environments test has a vulnerability, development has a vulnerability. It's like, okay, if I were a software engineer and I pushed code, or I'm getting ready to push code, I would hate it if my pull request looked like this every time I touched it. This is frankly obnoxious. You don't want to weigh down your coworkers with this. Um, Even if they know what it means, this is stuff that they have to read and make sense of. It's a waste of their time.
Also, it's very important to not piss off developers because
Yes.
then, like, if a tool is obnoxious, they will just ignore it, and if they ignore
Right.
it, then you're not doing anything. So
Right. So like if you're ignoring these because they're in files that you didn't touch, or you can actually see what I'm pointing at. If you ignore these because they're in files you didn't touch, you might instinctively ignore the one in the one you did touch because they all look the same. So Mark makes a great point. If you piss off your developers, not only will they be upset with you, but they're smart technical people. They will find ways to work around your roadblocks. So, like I mentioned, we didn't touch this. Why are we getting a finding for it? So this is going to be kind of the tuning phase where we reconfigure SemGrep to make it a bit more useful. And in this case, what we'll be doing is modifying it so that it only shows us findings for files that we're actually touching. So what we'll do is we'll update the GitHub action. So here's the updated copy. And then I'm going to go back into my fork, find the original SemGrep action, edit the file, and replace it. So I'll quickly show you what the changes are. So I renamed it to be improved. And then this is the most important part. What we've changed is we're actually no longer running SemGrep. So this command, the reason why it showed us vulnerabilities in files we didn't touch is that it actually, this command scans everything in your current directory. So we were looking at the application. So it did what we told it to. We told it to scan every single file. Instead, what we're doing is we're going to get a list of files that have changed in our GitHub pull request, and then we'll tell SemGrep to scan just those files. So now this is how we're looking at what files have changed, and then we're going to tell SemGrep, you know what, just scan those files. Don't scan anything else. Nothing more, nothing less.
by the way, does TJ Actions ring a bell to anyone? You've had to deal with it?
Incident, right?
Yeah. We'll talk about that in a bit, maybe under SCA.
Yeah. So yeah. Yes. So we're now only going to be running SemGrep. Excuse me. We're only going to be running SemGrep on files that have changed. So I've merged that. And then this is actually one thing that I really dislike about GitHub is that you can't easily trigger yeah, exactly. So you can't tell it to run again. So what I'm going to do is I'm going to edit this file and make a meaningless change. Typically, what you would do in the real world is one thing you could do is like you could close and reopen the pull request, or you could just push another commit to this pull request, which is what we're going to be doing. We're just going to push a bogus commit, and then just going to wait for that to finish. There's actually So this is kind of how you can get a view into your GitHub Actions, what it's actually doing. So checkout is downloading a copy of our code, specifically the version of the code that we're working with. We're getting a list of changed files, and it tells us the only file that's changed is app controller is just controller. And now we're going to be running SandGrep on just that file. Scanning one file, and then we should see findings 1. So earlier we had 13 findings. Now we've got 1. You can also get some interesting data like rules run 120. So this is probably because we're writing Ruby and there's not a whole lot of Ruby rules. Earlier, I think it said like literally in the thousands. And then if we go back to the pull request, now we only have this one finding. So this is a lot easier for a developer to read. It's contextual. There's no nonsense about files that they haven't touched. Even if they're all false positives, even if this one's a false positive, you know that you have just one to look at and it's in code that you wrote. So you have the mental context as a software engineer that, oh, I made this optimization. It found a bug in my optimization. So this is one way that you can tune. We've tuned it by limiting the files that it looks at. Other ways you could tune it is by reducing the severity or increasing the severity. Like if you know a certain rule is high severity in your context, you can just do it, make it a high severity rule. So what's up?
Is there any way that you can change the detections for the signatures of the vulnerability itself?
Oh, absolutely. That's a great question, actually. And I'll see if I can do that right this second, if it doesn't take more than a minute.
Yeah, that's fine. I was just curious. It worked like the same way that it does with detections, like for stimulus and stuff like that.
So we should be able to see the source code of the rule right now. So this is metadata. You know, it says this is a security rule. It applies for Rails. Here's some links that'll give you more info. And this is the signature. So absolutely, you can modify it. Are you familiar with Yara?
Yeah.
So I would say this is like Yara, but for code. This is you've got like your detections. This looks like the code that you're looking at. And I think this is actually, oh, sorry, this is the code that we wrote that introduced the issue. So yeah, if in your organization you find this rule could use a little bit more work, you can change it. And we've done that before. At work, we've found certain rules to be very false positive prone, and we've tweaked them to be more reliable, and then we'll actually push it upstream to SendGrab. That's kind of like, honestly, the lowest effort way for us to give back to the community is to help them maintain their own rules. So, Mark, you want to wrap up?
I'll do the first few slides, I think. But...
Yeah. So, what did we cover? We covered using SendGrep locally to find vulnerabilities. You know, we ran SendGrep on our code base. I would say if you're bored and want to get more familiar with it, run SendGrep on other people's code bases. GitHub is fully open source, so like git clone someone else's repo. You know, if you've used a security tool that you're kind of interested in, even if you don't know, if you're not familiar with the source code, run SendGrep on it, see what it has to say. If you work somewhere where they write software and you want to see if there's some vulnerabilities in there, just run SendGrep on it, see what happens. You know, if you don't work in security, it can be a fun way to start engaging with the security team. You know, I love it when my non-security colleagues say like, hey, I ran the security tool and it found these issues. Are these false positives? Let's talk it out. And also the most important thing is we tried introducing the vulnerability and we actually got blocked. I think if you try merging it, you should actually see it might not let you. Okay, I haven't set up this for my personal GitHub board, but in an enterprise setting, it would say merging is blocked because this test failed. So what's next for you? we just deployed SendGraph, but there's a lot of directions you can take it. One thing you might do is a staggered rollout. In our fake organization, we have just one repository to scan. But in an organization, in an enterprise setting, you might have tens, hundreds, even thousands of repositories to look at. So you might want to deploy them little by little. Also, you might want to say only look at high severity findings. And then once you've remediated those, you might say, okay, the developers are ready, they're familiar, let's show them medium severity findings, low severity findings. You might want to start collecting metrics. If you find that developers keep running into the same issues, that might be a good opportunity for internal education. You get the engineers in one room and you say like, hey, we all keep having SQL injection bugs. What's going on? And then notifications. One fun thing that some people like to do is have their GitHub action comment on the pull request saying, hey, you've got these issues. Sometimes they have these notifications. Like if you all use Slack, you might have a Slack notification going out saying, hey, this code that you're trying to introduce has a vulnerability. We have that set up, and we actually have that link to documentation so that people can say, okay, my code's got a vulnerability, but I can read the documentation to make sense of that finding.
And just one thing to add to that, it's one thing to surface findings, but then like what do you do with them? Where do they go? So like at my current org, we're rolling out ASPM, which is Application Security Posture Management, which is it aggregates findings from SemGrep and other tools and puts them in one place, and that's where you can like triage the findings and say like mark this one as false positive, and that way what you're sending to the developers is things you've already triaged. So surfacing findings through tools is one thing, and then how do you deliver them to the devs? What like are they responsible for looking at them straight in the pull request, or do you want to separately send them like make Jira tickets? So that's all. Like it just depends on the engineering org, but delivering findings and triaged findings is also very important.
Question or
Yeah. So for all the false positives, do you have the developers comment no SemGrep on every one of those lines?
so if are you talking about in our specific example with the
Could be your example, or it could be
so if it's in code that they introduced, we'll have a conversation with them. So we'll include in the documentation how to triage that this is a false positive or not. We'll include some basic steps like run the code, read the link in the finding, and see if it makes sense for you. For example, like one thing with SQL injection, if you're not talking to a database, a developer can read that's what it says and says, okay, I'm not touching a database, I'm good. But yeah, so generally we do say that. If we find that, so that's where like the metrics collection comes in, where if we find one rule in particular is being exempted all the time, we don't want that rule in our database or in our repository of rules. So we'll just straight up remove it. So one thing that I did mention is SemGrep has their community rules, but we've forked it internally so that we can actually delete it in our code base without having to delete it from SemGrep's code base, because that's not ours. We don't have the rights to do that. So we've actually had to delete, I think maybe 15 over the 2 years that we've been using SemGrep, especially because SemGrep is intended for a wide audience. So in our case, we write Ruby and Rails. They have Rails rules that go back to version of Rails from like literally 15 plus years ago. We don't use Rails that old, so we can just delete those.
yeah. So all your repos in the organization, or you just said there's one repo. Well, I mean, if there were multiple repos, they all pull from your like modified rule.
Yes, yeah.
When the action itself.
Yes. I can just briefly cover that. In this action where it's running SemGrep, we've just added a flag for a directory that says where the rules live, and it'll live in our fork of the repository.
I see.
So you can, we didn't specify a flag for where the rules are, because if you don't do that, it'll actually just download all the public ones and use those. But I think it's literally like --config. You give it a directory, and that directory can be a Git repository. So it's that for us. I thought also like the one thing that I recommend for anyone who runs SemGrep is like fork the rules so that you can delete stuff for yourself or add new stuff for yourself. Cool. So here's a little bonus. We've been writing YAML the whole time, and so YAML not strictly code in the sense that we're used to it. There's not branching, there's not variables in the same way you might find in like a Ruby or Python script, but it's still technically code, and just like code, it can have vulnerabilities. And so SemGrep can catch some vulnerabilities in GitHub Actions, but like with Rubocop for Ruby, you're often better off using a tool that's tailored to your language. And so in my case, I actually just open sourced this at work. So I work at Betterment, and we have this tool that I wrote to find vulnerabilities in GitHub Actions. And so it's come in handy because it's able to find vulnerabilities that SemGrep can't, or it can, but you would have to write very long rules for it because of some YAML specific issues. And so my tool takes that into account. It's also got a rules engine like SemGrep. So I actually modeled it after tools like Rubocop and SemGrep. So I'm hoping that it makes it easy for other people to write their own rules and modify ours. Cool.
Okay, so it mostly depends on which organization you're in. So you ask like, oh, are the community rules good enough, or should I use SemGrep Pro? So I recently ran into this when I was at Activision. We wanted to onboard a new SAST tool, and so so if someone asks you to do that, where do you start? And so at first we were like, okay, let's explore SemGrep. And at this point, you have the option between SemGrep Free and SemGrep Pro. So first of all, the difference is SemGrep Free, you're using community rules, but also you're analyzing every single file independently. Whereas SemGrep Pro gives you interfile analysis. Does that matter? It depends on which language you're using. Now, for languages like Ruby, and if you have like Ruby on Rails apps that many companies do, you already have incredible tooling like Rubocop, Brakeman, and RSpec, and so using just the default tooling, you get good static analysis. And the SemGrep rules for those are actually based on Brakeman rules anyway. So that's why it's very like language dependent. Now, for when I was at Activision, for example, Call of Duty is all C++. How do you scan that? So SemGrep does have C++ rules. A lot of the community rules are made by Marco Ivaldi, like 0x Raptor, I think was his handle. But so he has a lot of good rules. They do have a lot of false positives because it's analyzing every single file independently. Now, if you enable interfile analysis in C++, you get more accuracy. Well, the problem with C++ specifically is it just has very complex grammar. So any static analysis tool that isn't wrapping around the compiler is going to have a really, really high false positive rate. Now, there are use cases for that. For example, sometimes someone gives you just a code snippet out of context, like here's a small code snippet. Can you scan it, right? Or like it could be like one file or like a couple files like just out of context where like you can't even compile or build the whole project. In those cases, you can use SemGrep. It's fine. But the enterprisey tools like Coverity, it used to be Synopsys. I think it was acquired by. I think they called Black Duck now. I don't remember. Whatever. It's like an enterprisey scanner that is generally more effective for like large C++ projects because it's basically compiling the project to form like an AST to be able to like analyze and do like data flow and like basically give you more accurate results. So for C++, depending on the complexity of your code base, you might go with one of the more enterprise scanners or like Fortify or whatever. Obviously because they're enterprise, they have like bad UI, they're more annoying to deal with, and so then it's even more important to make sure you're sending the developers like fine-tuned triaged and like digested findings, because if you just send, or like, some people just give them raw access to the platform, like, hey, just look. And I feel like some developers don't mind it, but it can just be like a annoying experience to have to like log into Coverity and triage the findings yourself as a developer.
Yeah, that's like
So
a decision that you have to make for your organization. You know, some organizations you'll work with deeply technical people who don't mind doing that, and some people they might just be annoyed that you're asking them to do anything.
exactly, yeah. That's why like the company culture becomes important. So the company culture and like the languages you're using, do the languages have like the built-in good tooling already? Um, it depends. Like even things like ESLint, if they're writing JavaScript, it has like security modules. Like it's, you can use that if you want, right? So for SemGrep, I've asked around also a lot of people like, do you find the pro rules worth it? Like the interfile analysis. Some people have said like it was definitely worth it in their specific environments, but I felt like most of the feedback was that like if the rules that are really good end up being made or getting into the community rules anyway, and interfile analysis can be nice to like further reduce false positives, but in general it didn't seem absolutely necessary. So so like the approach that like seemed to work for most is what Omar described, that like you just fork the community rules, or like maintain your own like set of community rules, disable the ones that you don't need. You can even have like different rules per repo if you want. Um and yeah, I mean, there's also like the people writing community rules are really good. Like GitLab has their own repo of SemGrep rules. Trail of Bits has one. Um, there's a bunch of others. So, um, yeah, did that answer like your question?
Yeah, it does.
Um, so yeah, languages, frameworks, and engineering culture are all like things to consider when you're trying to pick which tool to use or which rules to use. Um, and then it's good to keep in mind like other less known tools, like for example analyzing GitHub Actions. Like it's actually not very common. There are a few SemGrep tools, I think you said, that
Yeah.
do GitHub action analysis, but like using a tool specialist for that, like your tool, is also nice to have. So there's edge cases that have like less support in mainstream tools. So that's for static analysis. That means you're analyzing your code line by line. So what about dynamic analysis? So let's talk about that a bit. So we said that one of the limitations of static analysis is that you're looking at the code, but um, what's in the code isn't always a perfect match to what ends up being deployed for many reasons. Like your build pipelines could inject something that you didn't know about, or what if you accidentally deployed from the wrong repo, right? There's scenarios where what's running in production doesn't match what's in the code, or there are issues that you can't catch only by looking at the code, like configuration issues where the config file is stored somewhere else. So um, when you're measuring security, you're measuring the security of the system as a whole, not just each component separately. And that's why looking at the code is just one component of the entire system. So we like to look at the final product. Now, often we say that static analysis is more in the like shift left mindset. Like you can catch things earlier. Like once the developer introduces the code, like it's a bit faster to catch and fix things. Whereas a dynamic analysis comes a bit later. You already deployed something. It could be in a test environment, but it takes slightly longer. So this is what I said, like the code is just one part of it. Load balancer could be like one portion of it. These are all like separate components, and you can analyze each one distinctly. But dynamic analysis tries to analyze the end product of what you're using. So what's the difference? Static analysis, you're looking at issues in the code, pattern matching. It's like running regular expressions that try to identify things in your code. And DAST is things in production that you know for a fact are there. Like you don't have to determine like, is this like is this actually an issue or not? Like, and that's like, like, okay, I found that this is an issue. Now I have to work backwards to figure out how it made its way into production or test environment. So it's good at catching low-hanging fruit, misconfigurations, but also sometimes it catches issues in third-party libraries or like frameworks that you're not the one who wrote, right? Well, one example is like WordPress, for example. If you're using WordPress, you're not writing the code, right? But you're using WordPress plugins. And so like the WP scan is technically a DAST tool because it's validating the plugins you're using for issues. So sometimes people ask like, hey, which one should I be using, SAS or DAST? Like, which one's better? It's like, no, this is no better. They're looking for different things. One is just looking in your code line by line, and the other is looking at the thing running in like the web page is being served by the server. Now, one interesting thing though is we often think of DAST as a web application scanner, often, but in your case, like you said, I'm looking at the communication. Like sometimes you have to analyze like a custom protocol, for example. It's not always a web application. Um, in the cases where you're analyzing custom protocol, for example, some people like to use fuzzing. And fuzzing, I consider it like a dynamic analysis because it's sending, random structured data and looking at the responses back and forth. So it ultimately depends what your application is. Usually you're looking at a web application, and so we use tools to scan web applications. So one example that is popular is Nuclei, made by Project Discovery. It's an open source tool, and so you can install it. Like here, like I had Brew installed it, and at the top, like Brew installed on Mac, and you can look up their documentation how to install it on your system, and you can specify. It's similar to SemGrep in that you can use custom tools, custom rules, but they call them templates. And there's like community templates. People they maintain a large repository of community templates, and you can have templates for specific things to look for. Like one of them here, I mentioned a few. One of them is missing security headers, HTTP headers. That's like a common use case for people. A lot of people like Bug Bounty or whatever, they like to flag missing security headers like, oh, you're missing CSP. And so like this is a quick way to check for them. Um, Another example is so we deployed Jester.social, right? And this was scanning it in production. Like it's up, it's basically a DigitalOcean droplet. I put the Docker file there and I deployed it that way. And then I pointed Nuclei at it and I was like, scan it. And so I asked it, there's a template called Rails debug mode, and it checks if Rails is actually deployed in debug mode, which I did. I deployed in debug mode, and so it detected it. It tells me like, oh, like I can tell that Jester.social is deployed in debug mode, which it gives you verbose error messages and things like that. So this is how you run it locally. That's like the exercise. If you wanted to spend time, basically you can check like Nuclei install, you can brew install it, or you can use their Docker container locally. And then if you want to run it, you specify the -ID is for the templates you want to run, and then at the end -u is your target. And in this case, it was Jester.social. So that's to run it locally. Now, more interesting is running it as a GitHub action. And so Dast is one of the like ideal tools to automate because I don't have to be manually running it once a week. It seems like a waste of time. Like I can just set up a GitHub action to do it for me on a cron schedule, right? So then like whatever schedule I want, the GitHub action just runs without me ever touching it, and it can be configured to send me the results in different ways. I didn't show it here, but at work, one of the GitHub actions I actually it just curls a Slack webhook. And so that way it just like on Slack, it just pings me a message on the channel saying like, hey, scan, I've run the scan and you can add whatever data you want there. But we'll see a few other options. So here's an example of a GitHub action to run Nuclei. And so Can I zoom just by doing
If you do,
this?
if
Oh,
you
I
hold
have to.
Control and scroll.
Oh, yeah, okay. Oops. Yeah, but then it doesn't.
And then you can move the mouse in the direction.
Oh, nice. Okay. So I commented out the cron job, in case someone forks it. I don't want it to like keep running like every. But you can schedule GitHub Actions on a cron schedule, so they run on whatever cadence you want. Then this is a neat one where you can specify workflow dispatch, and we'll see how it works. But basically, it unlocks a button where you can kick off the action in the GitHub UI directly. And then I'm specifying that I want to use the nuclei GitHub action, which they have published officially. And then here you just give it the flags. So my target is jester.social, and I gave it the same flags we saw earlier. A custom user agent just for easy in the log. If I'm ever looking at the logs of my own web app, I can tell what's happening there. And here the neat thing is this one. So GitHub report true. So that's built into nuclei, and that means it's going to open GitHub issues, and we'll see how they look like. But that way, like the results are just opened as issues in that repo. And then you can upload things as artifacts, which we'll look at later. So this is what it looks like in GitHub. So I mean you can do it in various ways. You can add the GitHub action in the repo of the code, but I like to have a separate repo just for automations, just to run GitHub Actions from. And so in that case, like that GitHub action was in that repo, I got it to run, and then it opened those issues. So on GitHub, like you can go to like the issues tab and you see it opened for every finding it found. It listed them here, and then you can click on them and it gives you all the details of like what exactly it found. Actually, I could probably show it. If I go to oops, no,
I think
not
it's
this,
the
not this.
next. Yeah.
Wait, no, this one maybe. Yeah, so this is the org, and I put it in the workflows repo. And so here you can actually, so first, if you go to actions, whenever you're in action, you can just go to the actions tab here. And here you see whenever an action ran. And for example, this was the nuclei scan. And you can click on it and you see the different steps, and you can click here to see the workflow file. And if you want to rerun it, you can just like rerun the job. But the issues it put what were here. So these are all findings from nuclei. And yeah, you can click on them. So you don't have to open GitHub issues. It's just one of many ways to handle findings. Again, that's like something to consider depending on your engineering culture, like who the audience is for those findings. But in this case, it gives you the details of the specific finding. Yeah.
Whois is actually deprecated.
Yeah. So this is looking for.
Oh, you're saying who is in general is deprecated?
Yeah,
Yeah.
yeah. The Whois has been deprecated.
Yeah.
The rest of them will be gone within 2 months.
Yeah.
Yeah, it's been replaced with RDAP, I think.
Yes, RDAP.
Yeah. So
So I
yeah.
think this is a template RDAP who is that it's just part of the nuclei. I don't know under the hood what exactly they're using to get this to get these results.
Yeah.
But
So I think this is doing enumeration. So like for an organization that's concerned about something like, do we still have who is enabled for our public domains? They might enable this specific rule so that I don't know, their sysadmins can actually go turn it off or switch over to RDAP.
Whois actually being blocked.
Right. So yeah. Yeah. So like if you run a large enterprise, you might not know all the domains you run. And so like a tool like this might get you a better handle on that. What's up?
Yeah, so every time I've deployed DAST, actually, let me put it this way: what's the most valuable finding that you've observed in DAST by validating?
yeah. So I know where you're getting at. So DAST sometimes can feel like it's a lot of effort for a very minimal benefit.
both security team and developers.
Yeah.
This is why like the
So
tuning is very important.
right. And that's why also automation is important. So sometimes you'll join a company and they're like, we need to buy one of those like enterprise DAS tools like Tenable, and where like it goes like a full full web app scan. And so I haven't really gotten good results from those, but that's actually why I prefer doing like a GitHub Action that just runs nuclei. And really the main benefit is to validate like very low hanging fruit. So there's a few use cases. One is regressions of known vulnerabilities.
Yeah.
So sometimes you have like that like an endpoint was accidentally exposed through a misconfiguration. So you can just like try to curl it and expect a 404, and if it returns anything else, it alerts you. That's one
You could
example.
write that as a template for nuclei.
Yeah. And
You can make custom.
you can, yeah, you can. I mean, it depends. So the rules here, for example, this one is TLS versions. Like it's just easy. It's just for compliance. It's really just for compliance. Sometimes like you'll have a customer and they're like you cannot ever support TLS 1.1, and you're like, okay, you'll have this, and if it ever finds TLS 1.1 supported, it just alerts you. And it's so there's some like minor, like sometimes you have contractual agreements and they ask for really low hanging fruit like that, like TLS config or like HTTP headers, and like also sometimes if you have like bug bounty and you don't want to keep paying off like for like small misconfigs, like they're gonna be scanning for this stuff anyway, so might as well already get a handle on it. But usually it's for like these like minor issues. The most significant ones are like regressions or like misconfigurations that accidentally expose like an admin panel or something like that.
Yeah, so like for us, the TLS thing is, um, so working in finance, like there's a lot of regulations that say you cannot be running anything below TLS 1.2. And so you can say very easily, like for example, in AWS, uh, we have configurations in AWS that says you cannot spin up any infrastructure that uses anything below TLS 1.2. But that doesn't stop us from like creating a subdomain that points at an IP address that's running TLS 1.1. Like that's always possible.
Right.
And Nuclei will catch something like that because it says, I don't know, garbage.mywebsite.com is running TLS 1.1. I actually, it caught a really neat regression because at work, when we moved to Kubernetes, we were sending our security headers, so like X-frame options, content security policy, these were configured at the web server level. And when we switched from old school Linux web servers to Kubernetes, they actually forgot to move that
Nice.
header over. And it wasn't Nuclei that we were using at the time. I actually forget what we were using, but it spotted that these security headers were no longer being sent by the same domain.
But on this box, Nuclei doesn't try to profile the application version and
No. Yeah, so that's going to be like the upfront heavy lifting you'll need to do.
Yeah.
But it depends on your configuration. So like in the example Mark set up, he tailored it to the application.
I just picked some rules I thought were more relevant. So that it's a good point, because actually a lot of people do just use default config of a rule, like, hey, let's enable everything. But then you just go get overwhelmed, because like the rules aren't, a lot of the rules aren't going to be relevant for you. And so what are you looking at? Like a lot of like default output and verbose like information that is that really, is there anything to fix here? Is that why would I run WP scan when I'm not even using WordPress, and that is just taking time, and it's like false positives. So usually you look at the rules and you're like, well, which ones seem interesting to me? And then you pick those, and you start with those. I would say that scanning less with a subset of rules, to me seems when you're deliberately picking the rules, seems more effective than just like default config, scan everything. You have a billion findings and then you ignore them, right? But yeah, so because the effectiveness of DAS just depends on, I generally I usually prioritize SaaS first, and generally I'm content with not paying for, I mean, it always depends on your budget and the size of your team and how many resources you can dedicate, but usually Like if you just run a GitHub action, you run nuclei or something like that, that's usually good enough for that. So you don't have to like pay Tenable or like one of those like enterprise, because the problem then is like once you pay for it, one, you're paying for it, two, now it costs you even more to tune it, tweak the configuration, look at the results, and it's not just the acquiring a tool that's costly, it's the running costs, and now you need a full-time person to just like handle that and their findings. And so, finding a balance as hard as it usually depends on the size of your team and things like that. Okay, so another example. So we do discover nuclei. Another example of DAST is Nmap. I consider Nmap a dynamic analysis tool. So Nmap, you're just looking at different ports, and you can enable a lot of scripts. That's where the value comes, is the Nmap scripts. And there are scripts that look at like web app stuff that can flag like misconfigurations. Also for compliance, sometimes it's nice to know if like a port was inadvertently opened through whatever misconfiguration. So here you're really catching like just misconfigurations, or like someone accidentally changed the security groups or the firewalls, right? So it really doesn't cost you much to just like have a weekly Nmap scan where it's just flagging. Also, these are, you have access to the org, so you can look at the repo and just copy paste this into your own. We're gonna ask something.
Yeah, I noticed that the tool only supports IPv4. The world already has IPv6.
Which tool?
Which tool? Nuclei? Really? I thought it had an IPv6 support. No?
Well, it's IPv6.
Oh, interesting. Okay, interesting. Yeah.
That's a big deal because
Yeah.
a lot of the large companies are doing V6 only in some cases for advertising purposes.
Oh.
And yeah, that's kind of a big deal.
So
Yeah.
yeah.
That's interesting because so in a tool like Nuclei, you're scanning what's hosted on the IP. So in some modules, like it depends on what you're trying to scan. In some modules, it might matter. Some not really. For tools like Nmap, that matters more because you're scanning the infrastructure directly. So you do want to make sure that it scans both IPv4 and IPv6. So that's a good distinction to make. But yeah, it really depends. If you're scanning just the application itself that's hosted, it usually doesn't matter if. I mean, you want to validate that's what hosted on IPv6 and IPv4 is the same if you're hosting on both. Um, but yeah, if you're only hosting IPv6, then yeah, I guess you'll have to find a configure or some other way to reach it.
It was 600 billion or 6 billion
Mm-hmm.
devices that have had IPv6 starting 5 years ago.
Mm-hmm. Yeah,
Yeah.
it's getting more.
So that's actually great that you mentioned that, because if you're at an org where you're deploying a tool like this, Nuclei is already out of the picture. You cannot deploy a tool like this if it can't even reach your infrastructure. So that's going to be like when you're in the meeting room with the people who are deploying this or the people who are funding this work, you tell them this one, just cross off your list and let's keep looking at the other four or whatever.
Mhm.
Or just you can use RAS proxy, you can use a whole bunch of other techniques, but then you also have to validate other things.
Yeah.
You can create if you do the DNS lookup, you
Mhm.
can use sub DNS lookups, you can basically then look up V4 and V6, have
Right.
both of them. The default is V4 is pretty much I want to go from here to here instead
Mhm.
of unique addresses.
Right. Yeah.
And same thing, Tenable has exactly the same problem. They've never fixed it.
Oh, really? Okay. Yeah.
Yeah, and it's good that you know these things, because when you go into this decision-making process, if you don't know this, you'll run Nuclei and it'll say you've got 0 findings. It doesn't tell you that
Right.
it couldn't reach this service in the first place.
And that's a common challenge when the more you drift away from, like the more your configuration is unique, the more you just have to. That's why like sometimes the only solution is like make your own bespoke tools like in-house, where like worst case you're gonna have to do that if your setup is completely like at Activision, their whole build pipeline was completely bespoke. So a lot of the tooling, you would think like, oh, they would say like, oh, just integrate into GitHub. It's like we don't use GitHub. It's all Perforce in gaming. And then even then, it's all custom build pipelines. And so a lot of the stuff is you have to build your own scripting on top to make things work. So yeah, it just depends. Yeah. Mhm.
Yeah, I have a question. I know with the DAS tools, some of them, uh, they support, username and password for authentication.
Yeah.
How are we doing this here? Or is this primarily like,
Yeah, so this is unauthenticated, but that's a great question. So it depends. The easiest way to do it is an authorization header, authorization bearer token, and you send in the header, but not all apps support that. So what do you do then? So it depends on the tool. Some of them support cookie-based authentication. Some of them you have to provide the cookie yourself. Um, some challenges sometimes like you use a authentication provider like Auth0, which a lot of tools like don't provide. So then you might have to like have your own script that like logs in, fetches the cookie, and gives it to the tool. It depends on each scenario. Um, do you have a
Yeah, I mean, honestly, I haven't used a lot of DAS tools that do authentication
happy with
that I've been happy with. So uh, I choose to avoid it where possible. So like what Mark was talking about with configuration related issues, that's where I find DAS to be super useful, where it's like making sure that unsupported versions of TLS never show up, making sure that my security headers show up. I've never found a DAS tool that can authenticate to my custom Rails web app and find a vulnerability by clicking around in the interface or simulating
Yeah,
clicking around in.
yeah, same, yeah.
I'd be curious to hear if you have had success with any tool like that.
Yeah,
Okay. Okay. Yeah.
he said the only things that it catches is like, the flag and cookies not
Right,
found.
right, right,
Right.
right.
There's so much.
Are you looking for the actual version of Ruby and Java and things like that?
Sometimes, yeah. So one thing that Mark mentioned was for example, like WordPress plugins. And so like WordPress will tell you the versions of the plugins, it'll tell you the version of the PHP runtime underneath. And other languages and frameworks do the same thing.
Java basically they had all 24 versions open, and there's code out there that goes from Java 1 to all the way to Java 24. The duplicate didn't work until they finally realized, okay, I was talking to them about it for the last 6 years.
Oh, nice.
Once they actually updated it, it worked. It also fixed a bunch of other security problems.
Oh,
Nice.
yeah.
So that's another domain right
Yeah.
now. It's the libraries for programming languages.
Yeah,
Exactly.
yeah. So
Yeah.
we'll talk about that a little bit. But so the DAS tools have modules to try to fingerprint. The accuracy depends on each framework. Like some of them, it can very easily give you accurate version, but sometimes it's not very accurate. So it depends. Like in the web app, I gave an example because I have debug mode enabled. From the debug mode, it just tells you the Ruby version and the Rails version. So um, okay, so Nmap, same thing. You can run it in GitHub Actions. We have a GitHub action you can copy and use. But essentially, it's just you can have a generic GitHub action which runs a script, and in the script you can define apt install nmap and run it. I even have like a few steps to convert the output into a PDF. For whatever reason, like you want to send it to the compliance team or something, and so you can attach here at the bottom. There's a GitHub Actions module called upload artifact, and you can tell it which file to upload as an artifact, and that means attached when you open the GitHub action, it just attaches whatever you want here, and you can download it as a zip file, and inside it, you would find the PDF or whatever you chose to attach as an artifact. So overall in Dast, so running them as on a schedule as cron jobs is useful. You're usually not gonna rely on it for like heavy testing. It's mostly for finding low-hanging fruits. And some of the questions you might ask is like, what languages am I using? How often am I going to look at the findings? What works best for me? Who's going to be triaging the findings? Who's going to be looking at the findings? And so, yeah, you have options. Like there's commercial tools like Tenable. There's like Zap is a good. They have Zap. They have a GitHub Action as well. You can just use their GitHub Action. You can use Burp Suite. So Burp Suite is good. It's a great pen testing tool for web apps. You can just use the active scanner they have, which is DAST, to crawl an app. If you want to automate it in the pipeline, I believe you need an enterprise license um, to do that. So
Like have it start.
Is that what happens?
That's what happens.
oh, I see. Okay, yeah. Um, yeah. So those are good tools. So SAST is what we covered. What else? So we are kind of running out of time. So we're gonna go very quickly over like some of the other stuff that we do in security engineering. So one other thing is secret scanning. So the idea is like when we're looking in the code, sometimes there's hard-coded secrets. Um, what's wrong with hard-coded secrets? So at the surface levels, anyone with access to the code would have access to secrets, and then they can abuse those. And sometimes if they access the secret directly, there's no auditability because the secret's associated with like a service account, for example, so they can abuse it without knowing who's using it. But also sometimes your code gets leaked. Sometimes a configuration file, something I've seen is like someone accidentally pushes a configuration file and makes it publicly available. And you think like, oh, it's just a config file, but those config files sometimes accidentally end up having secrets in them, being exposed to the public. And that could be, SSH access or GitHub Write access or AWS access, right? Like all sorts of stuff. You can like read like S3 private buckets or whatever. So breach of confidentiality. And we know that there's actors that just continuously scan GitHub and private repos for secrets all the time. So what are the tools you can use for that? So one of the big providers of secret scanning is Trufflehog. So I actually recently found out that they have a Chrome extension that you can use, and while you're browsing the web, it'll pop up like, "Hey, I found a secret in the source code of the." Yeah, it's pretty cool. But there's actually a lot of hard-coded tokens in web pages, so I don't know how useful it is. Like it keeps popping up every occasionally. Anyway, but so Trufflehog is a good tool. There's also Git leaks. Um, it doesn't really matter. SemGrep also has a secret scanning module, but the main thing to look out for is how are they doing the secret scanning. So the most basic level is just pattern matching. So for example, begin RSA private key, looking at for that string, you found a private key, good. But looking for passwords, slightly more complex because what is a password? It depends. Like password 1 2 3 is a password, but also like a very long string that looks like a line of code could be a password technically, right? So the way some of these tools do it is by flagging high entropy strings, right? So like strings with just like a lot of chaotic variation in letters, basically. So that can be good to flag secrets, but the limitation is that you end up uh, flagging a lot of just like long function names. Like if you have a really long, a big code base with a lot of function names that are long, it flags every single one of them as a potential like high entropy string. So it's just annoying to triage those. Um, so if you want to take it to the next level, you can do Git pre-commit hooks. So that way, like your developers, before they even commit the change into Git or push it to GitHub, the secret scanner runs and flags like, hey, you have something in your code that might be a token. And another thing to look out for is like some tools. I think they both do with Git leaks and Travelhog, but they also look in your commit history itself. And like in Git, it's not just the code you have; it's also like previous commits and even like the commit messages themselves. They look in all of those for potential secrets. So that's one thing to do that's useful. Secrets is actually more you have more findings than DAST. I think that ideally you find nothing, but occasionally you're like, oh shit, like someone accidentally left a private key, because mistakes happen. That's fine. And so another big project or process is a component of security engineering is SCA, software composition analysis. So when we're talking about SaaS, it's usually first-party code or like code my developers write. But not all of the code we use is code we write. A lot of the code we use is code other people write. And so that's like dependencies and libraries in our code. So how do we assess those? That's where SCA tools come in. Now, like we said in the last portion, when I'm responsible for security, I'm responsible for the system as a whole, not just components. So even if I'm scanning my own code, the system as a whole contains code and libraries by other people. So I should also make sure I'm aware of vulnerabilities in those libraries. And because an attacker can exploit the vulnerability in a library, they don't need to exploit my own code. And either way, they're going to gain access to my system. Now, software composition analysis, usually you think of software libraries. And so in Ruby, you're talking about Ruby gems. In Python, for example, you can look at the requirements.txt file for all of the dependencies used in a repo. It depends on the framework you're using. And one of my favorite tools for that is Dependabot. So it used to be its own company, then GitHub acquired it, and now so you don't like you just enable Dependabot by clicking a box in GitHub, and it starts scanning your dependencies. So it's good to enable that. Now the challenge is making sure developers are actually updating their dependencies, because you'll enable it, then you have 17 trillion findings, and developers are like, I'm just going to ignore this, and nothing ever happens. So you have to come up with a process where like, okay, can we actually start updating on a cadence, right? Like can you, like, we know there's vulnerabilities in these packages. Maybe start by updating these 2 packages. That eliminates a chunk, right? The process here is kind of more important than the tool. Another challenge with SCA is the false positive rate is relatively high because the tool will tell you if a package is vulnerable based on its version number. Now, if I'm using a vulnerable package based on the version number, it's not necessarily true that I'm using the vulnerable component of that software, right? So often it'll tell you like, oh, you're using a vulnerable version of like Nokogiri or whatever, but it's actually the vulnerable code is something I don't use at all, so I'm actually not vulnerable at all, right? So in those cases, you can deprioritize those. It's still a good idea to fix them because eventually someone else might start, like they're like, oh, we already have this dependency installed, I can just start using like this part of it, and eventually they can start using the vulnerable code. So you still ideally want to fix it at some point, but in general, there's a high level of false positive rates with SCA. So next level is like automatically merging. Like you can tell Dependabot to open PRs and automatically merge them. Some developers like it. Some developers are actually terrified of the idea of auto merging PRs. That's like, depends on the quality of your test cases, I guess. But so here we've been talking about software dependencies. Now, something to mention is you have dependencies that are not just software. Like obviously at the infrastructure level, you have like packages installed, but in your pipeline as well. And that comes back to the example of TJ Actions. So we were using GitHub Actions, right? And sometimes you're using third-party GitHub Actions, and sometimes those GitHub Actions can be vulnerable. Now, if you want to analyze the code of the GitHub action itself, you use a tool like Clause, but sometimes you can use tools that tell you if the version of actually there aren't that many. There aren't that many, but that's actually relatively new. There was this whole debate of like, how do I make sure I'm not using vulnerable GitHub Actions? And so one of the challenges was that once you start using GitHub Action, that's just running in your CI. Like it's just code that's running in your CI, and you're always pulling the latest version. And so what happened with TJ Actions was that it was like a sophisticated phishing, I guess, or they ended up pushing malicious code to that action. And so everyone who was using that GitHub action was running malicious code in their pipelines. Now, their pipelines are pretty spicy because they have like environment variables that are secrets. So how do you prevent that? And it's actually not very easy. So a lot of people will tell you like, oh, just pin the GitHub action by commit hash. And so when you're using GitHub action, instead of specifying like instead of always using the latest version of it or specifying it by tag, like use version 1.9, you should use this version of the GitHub action and specify the commit hash. So that is generally good in that you would prevent, if that specific GitHub action was compromised, you wouldn't be running the malicious code that they push to later versions. You can also fork the GitHub action, maintain your own version. But one limitation of that, or one area it doesn't fix, is that you have transitive dependencies. And so sometimes the GitHub action you're using in turn uses other GitHub actions. So you can pin that GitHub action, but are they pinning their GitHub actions that they're using? Because then if one of the actions they use is compromised, then that ends up affecting you as well. So that's like part of the whole like supply chain attack discussion, and it's not. I would say it's like kind of unsolved in that like the way we push code right now and use dependencies. Um, we just very liberally use third-party libraries, and it's very hard to have a handle on that because it's kind of like an all or nothing thing. If you want to start like allow listing particular dependencies, then it just takes a lot of effort to say like these are the approved ones, and then it's like someone tells you, well, I want to use this new dependency. Like, how are you going to review it? Well, maybe if it's GitHub action, you use clause, but then like, how much effort are you going to spend making sure that that dependency is secure? So it kind of depends on your risk appetite. Like if you're in if you work for the government in a super secret like Air Force base, like you're probably going to go through the effort of doing that. But if you're a small web app company, like then it's okay. You want to kind of like move fast and deploy a lot of changes. You probably can't afford to like review every single GitHub actions that someone wants to use. So then it kind of depends. Okay, so we talked about a lot of things. Closing, you want to do the...
Sure. So we talked a lot about the software development lifecycle. We started talking about what that is and kind of how it can be tricky to secure it. And most importantly, securing it is just a lot more costly the later in the lifecycle you are. And so our goal is to automate as much of that as possible to multiply the impact that we can have. We covered two very specific tools and some smaller or some other tools in lesser detail. And so just to reiterate from the beginning, our goal is not to tell you about any one specific tool. We cover nuclei, but it turns out it doesn't support IPv6. So the idea is that you should be able to swap out nuclei for any other DAS tool and hopefully walk away with roughly the same impact. So the concepts are a lot more important. We talked a lot about how you can interface with your coworkers. These are people, they're humans, they do not like being annoyed, much like you don't like being annoyed. And so you don't want to be the one annoying them. You don't want to be the reason why they're annoyed. And so when deploying, whether it's SaaS, DAS, secrets detection, anything, you want to make sure that you're not inundating your coworkers. And that's about it. Thank you all for coming. We have a feedback form here. You don't have to fill it out if you don't want to, but we would really appreciate it. But also that contains our LinkedIn information, which some of you all care about, some of you don't, in which case there's nothing for you to do.